While you're doing.
All right, let's see the other one.
Oops. I won't blow it up that much, but I did. Here, I'll still will. Tell me whenever you're ready, Bradley.
I'm ready.
Okay. I didn't really need to draw this picture, but I wanted to for the first one here.
Okay.
Tell you what's going on. If I translate that triangle that I've drawn by this vector, then I'm going to do what to each x coordinate?
Subtract 1 from...
No, what to each x coordinate? The 4 is the x direction, the -1 is the y direction.
Oh, add 4 to 1 and 6, and then...
No, just to the 1. In other words, my a prime is going to be 1 plus 4 and 6 minus 1.
Okay.
So that's a prime. Tell me what b prime is going to be.
7 and 1.
Notice that that's all we have to do. I don't need a picture. I just need to know how to handle a vector translation. So what's c prime going to be?
It will be 8 and 6.
So I could have done that without my drawing. And that's the way I do the rest of these, is without the drawing. Okay. 15 next. What's the red thing on the 15 mean? Is this a bonus question?
I have no idea what that means.
Yeah, I don't see anything special about this. What's m prime?
It will be 2 and 0.
What's n prime?
It will be 3 and -3.
And p prime?
6 and -1.
And there you have it. Rectangle is really no different. In other words, instead of having 3 vertices, I've got 4. So q prime?
It will be -6, 1.
You add the two numbers. It's -6 and 7. You don't subtract them. You see how you got -6? You added -8 and 2.
Oh yeah. And then
R prime?
it will be -6, 5.
S prime?
-1, 5.
And T prime?
-1, 7.
Yeah, so that's a rectangle that's parallel with the axis is. Okay. How about 17?
No, 1 second. I'm going to tell my brother to turn the music down.
Okay.
All right, I'm back.
Okay. So the only difference between 17 and 16 is 17 is a quadrilateral, a four-sided figure. It's not a rectangle. It doesn't matter. Quadrilateral still has 4 vertices. So f prime is going to be what?
-9, -4,
G prime,
-6, -3
H prime,
would be -5, -6
and J prime.
would be -8, -8.
Easiest math you've had in 5 years, I'll bet.
Yeah.
Yeah, it's just addition. That's all it is. Okay, trapezoid. That's a four-sided figure also. No difference. You take each vertex and you add the vector. So I think you got the hang of this. Shall we go to the next page?
Yeah.
You got the hang of it. Not sure oh yeah, I can.
It's 23 and 24.
Let me open it up with my editor here. Okay.
It's 24, 25.
Yeah. Okay, let me zoom in just once. Now here, they're telling us or showing us the translated figure, and they're asking for what the translation vector is. So it doesn't say whether you're going from blue to green. Can we tell anyway?
The X.
What's it say at the top above 23?
That's just for a different problem.
Okay.
Yeah.
Well, it doesn't really matter. We can pick a direction. Now, obviously, if we're going the other direction, the translation vector is going to be exactly the same, only with negative signs on it. So let's go from blue to green. What is the translation vector going to be when I go from blue to green? As all you really need to do is do 1 point. In other words, take that point and figure out how it gets there.
Okay, so 1, 2. So 5 over.
Hold it. Do the x first, because the x is the first you write. In other words,
So,
we're not doing slope. A lot of times in math, the y comes first and the x comes second, but most of the time the x comes first and the y comes second. So you generally want to do it in whatever order our answer is going to be, which is the x first, comma, the y. So what's the x movement?
3.
What's the y movement?
5.
Plus or minus?
Minus.
Because we're going down. Now, notice that if I was going from green to blue, it would have been -3 up 5. So that's the only difference. Depending on whether you're going from blue to green, this is blue to green, this is green to blue.
Okay.
Okay? So we don't really care which they mean as the original. What's the translation vector if I go from blue to green? We'll go blue to green.
Okay, it would be 6, -6.
Sign's very important. That tells you whether you want to go left or right. Okay?
4. -6.
Yep. These translation vectors are easy. It's when they start rotating them that it becomes a little tougher. 23 and 24 were the only two we had to do?
And hold on, I'll look on my phone. And 25.
Okay. Whoops. Here, let me pull it up a little bit. Notice that you can imagine a concert hall being the same way as translating vertices. Last year, you were in seats C3 through C6. This year, you're going to be in D16 through D19. So what is my horizontal translation? Well, let's look at the picture too. In other words, we were in these 4 seats last year. This year, we're in these 4 seats. So how do you get from these 4 seats to those 4 seats?
You go up. You go
Always
to the right. You go
to the X first.
You go to the right 10 times. No, not 10. 13 times.
Yeah, do it seat for seat. In other words, 3 becomes 16.
Okay, so that would, okay. 13 and then 1.
Correct. Now, they don't really... Yeah, that's about the only thing we can do based on their diagram. It's not completely clear that 13 is to the right. If you're in an auditorium, 13 could be going to the left. But in this case, 13 is to the right. Okay. Okay. Well, that's the last problem on that page, I think.
All right, I'll send you a picture. There's.
I was wrong, huh? We're going to need more than one picture, or 2. Of course, I didn't realize that there was only 1 or 2 problems each page, and they were easy problems.
Yeah. 6, 3, 6.
Why so many shutter clicks? Why so many shutter clicks? Just out of curiosity. I just don't understand. Aren't you?
Understand.
Okay, I got it now.
She wants me to only do 16 and 18 on this page.
16 and 18, okay.
Yeah.
Okay, rotations are harder, but not if you always use the exact same format. First of all, are these rotations clockwise or counterclockwise? Do we know?
I have no idea.
I think they're, it is going to matter. It's not going to matter on 16 because it's 180 degrees. So those would be the same way. But it will matter on 18. I'm trying to remember. Most math goes counterclockwise, but I think these are clockwise. I think these are clockwise. So let's look at 16 and 18, right?
Yeah.
I'm going to draw a picture because it definitely helps on these. So 16 has 2, 4. That's F. 5, 6.
5, 6.
That's G. And 7, 2. That's H. Now, when you rotate about the origin, you just take any vertex you want. Let's call F. I'm going to connect it to the origin with a dotted line. And that dotted line is what I'm going to rotate. In this case, I'm going to rotate it 180 degrees. In other words, and like I said, 180 degrees doesn't matter whether you go clockwise or counterclockwise, you end up in the same place. In other words, my new point F is going to be right there. That's going to be F prime. You see why?
Because you rotated 180 degrees.
Yeah. So my new point H, in other words, if I do the same thing with H, H ends up right there. So that's my new points H prime. And if I do the same thing with G, I'm not sure I have to necessarily do that, but it does give you an idea of how that triangle is going to look after we rotate it. That's G prime. Connect the triangle. And that's what it looks like when it's been rotated 180 degrees. And there's something else that's worth knowing. Here, let me label some of these points. F was 2, 4. What's F prime? This is F prime down here.
It would be -2, -4.
Yeah, when you do a 180 degree rotation, you just flip the signs on both coordinates. Okay. H was 7, 2. So the new H should be -7, -2. And it looks to be that. In other words, it's in the right position to be -7, -2. The G was 5, 6. So it should go to -5, -6. I may not have drawn it perfectly, but there's nothing greatly out of whack here.
Yeah.
So that's something that's actually worth memorizing, that when you do a 180 degree rotation, you don't have to draw pictures or do any of this. Just make F prime -2, -4, and so forth and so on. And it turns out that each 90 degree rotation has a different system. When I do a 90 degree rotation, we're going to discover something about the coordinates that is an interesting fact to also memorize. Okay,
Okay.
let's
Can we just do like 14 and
sure.
14 too, since it's 90, and it will probably be.
Yeah. Okay, 14. I'm going to draw again. Two comma 6. That's J. K is 5 comma 2. And L is 7 comma 5. Notice I just approximate. That's all you really need to do. You don't need to draw a grid and get it exact. So there's our triangle. We're going to rotate it 90 degrees. That means this dotted line that connects that has to become that. In other words, I'm going to do a 90-degree rotation. Okay, so this is my K prime down there. What are its coordinates?
It would be negative 5, 2.
X is positive.
So
this is not 180 degrees, so you can't just make both signs opposite. Does that look like plus? They are the same numbers always. No matter what the degree rotation, the numbers don't change. So the X coordinate is either plus 2 or plus 5. What does it look like?
Plus 2.
Okay. And the Y coordinate of K prime looks like what?
Minus 5.
Yeah. In other words, the only thing you have to do is get the signs right. So with a 90-degree rotation, we switch the numbers and switch the sign on the Y coordinate. That's all we do.
Okay.
Notice that if I were to do another 90-degree rotation,
it would be,
well, K double prime. I switch the numbers and switch the sign on the Y. So I get that. Now that fits exactly how we do a 180-degree rotation. We just switch the signs on both.
Okay.
That's one way to kind of check yourself as to make sure you're doing it right, is I know what 180-degree rotations mean. These others are a little harder to memorize. I'm not sure you necessarily have to memorize them. As long as you can draw a picture, then I can figure out what K prime is, right? It certainly is not 5 comma minus 2. It's got to either be 2 comma minus 5. That's the only possible answer. In other words, that's a right angle right there. Okay? So now that we know what the system is, tell me what J prime is.
J would be 6 negative 2.
And L prime?
Would be 5 negative 7.
Correct. So that's what you do with a 90-degree rotation. Now, do 18 that has the 270. In other words, that'll be all. If we can do a 90, a 180, and a 270, we got it licked.
Okay.
Probably if I erase everything and redraw it, I'm best off. 18. To be honest with you, I don't remember these formulas as to how you changed to the translated one, but you can always figure it out. In other words, if you can always figure it out, then that's all that matters. Okay? So minus 6, there's R. Minus 6 comma minus 1. S minus 4 minus 5. There's S minus 4 minus 5. And finally T, which is at minus 2 minus 1. So that's right about there. That's T minus 2 comma minus 1. And our triangle is like that. Now this time I'm going to take that dotted line and I'm going to rotate it not to here, not to there, but all the way around so that this angle is 270 degrees clockwise. With me?
Yeah.
Which would be the same thing as a 90 degrees counterclockwise rotation.
Yes.
Just to understand that.
Yeah.
Okay, now let's figure out what these points are going to be. Well, let's see. My T prime goes to right here. If T was minus 2 minus 1, what do you think T prime might be?
2, negative 1. Or 1.
Hard to tell, isn't it?
Yeah.
Okay. The reason it's hard to tell is because these two numbers are close together. So when I do my rotation, I can't tell from my picture what the answer is. So there's a solution to that. Pick the numbers that are further apart from one another. For example, R prime. Okay? R prime, if I connect the dotted line with R to the origin, I know that R is going to be down here, right?
Yeah.
So that's R prime. Now, because the numbers are so far apart, it's easy to figure out what they are. What do they have to be?
1, negative 6.
So with a 270 degrees rotation, what you do is you switch the numbers and you change the sign on the left number. Well, on the y coordinate, you change the sign. Switch the numbers and change the sign on the y. Isn't that exactly what we did with a 90 degree rotation? I think it is.
Yeah.
I think we switched the numbers, but it shouldn't be. No, it couldn't have been the same. Because at 270, I would have to rotate that 180 to get to a 90 degree rotation. So 90 degrees is not the same as 270. It just looked, I can't remember our formula for the 90 degree, but now that we looked at two coordinates that were far apart, and by that I mean 6 and 1, 6 and 1 are far apart, which puts it a lot closer to the x-axis than it does the y-axis. So after I rotate it, I can figure out that the 6 must be the y-coordinate, and the 1 has to be the x-coordinate, and the 1 is positive. So I guess what I did was change the sign on the x-coordinate. Now tell me what S prime is.
It is 5, negative 4.
And T prime.
1, negative 2.
Yeah, that is different because before we were changing the sign on the y spot. So the lesson you really want to take out of this, Brad, is, excuse me, Bradley, is not memorizing those three formulas?
It's the dotted lines.
Well, that, and also notice how difficult it is to figure out that formula if my 2 points are close together. In other words, P had numbers of 2 and 1, or -2 and -1. Well, those are so close together that after I rotate it, I can't figure out which one should be further away.
Yeah.
R, because R is at -6, -1, way over here, well, I know that when I rotate it, it's going to be way down there. And now there's no problem figuring out what these two numbers have to be, right? We know the numbers never change. It's just they switch positions and change signs. That's all they do. Well, clearly, the only thing that works for R, if I have to use the numbers 1 and 6, is +1 -6. And I can tell that from my picture. But I can only tell it because 6 and 1 are far apart. Notice I wouldn't be able to tell it very well with the S point either.
Yeah, because they're 4 and -4 and negative.
4 and 5, they're right next to each other. In other words, if I connect that and then rotate it, I can't tell where that point is. I can't tell whether it's where the 4 is the X or the 5 is the X. So if they ever give you a triangle that's got 3 points that are all right next to one another, make up a point like R, rotate it, that will tell you the formula you need to use. You see what I'm saying?
Yeah.
In other words, if they were to give you a triangle that you couldn't figure out, add a point, rotate it, figure out the formula for that point, and then use that formula for the 3 points that you can't figure out.
Okay.
Okay.
Yeah.
What else?
Let me look. That might be it.
16 and 18. We got 15 minutes. Want to do 19 and see if the same formula holds? I bet it does.
Yeah. Because that's the only pages she has in the.
All right.
For the book.
So, first of all I'm going to do 19 is 1 point. And that's going to tell us the formula, right?
Yeah.
Okay. Which point should I pick?
-7, -2.
Yeah, V. Well, -7, -2 is about there. Okay, so that's V prime. I'm going to connect that. I'm going to do a 270 degrees clockwise rotation. There's my, whoops, hold on, I didn't draw it quite accurately enough. Got to make sure I draw a right angle. And that puts it down here. So if V is -7 -2, and I know V prime has to use the same numbers, what do they have to be?
2 -7.
So that is the same exact formula as we used for 18.
Yeah.
In other words, whenever you do a 270 degree rotation, you flip the sign on the y coordinate and switch the numbers. So that's all I have to do for every one of the vertices on 19.
Okay.
Is flip the sign and every one of the numbers. Oh, excuse me. Flip the sign on the y coordinate, the -2, and then swap the numbers. So that's what I'm going to do. Here, let me. M prime.
M would be -3, -6.
What is P prime?
-3, -2.
What is Q prime?
2, -3.
You got it. I would say it's as simple as that, but it's not quite that simple. You have 3 different rotations. Obviously, a 360-degree rotation puts it back in the same spot. So
Yeah.
the only rotations that are difficult are 90, 180, and 270. And like I said, you can always just plot a point and figure out, I don't care what kind of problem they're dealing with. If they say, let's do a 270-degree rotation, pick a point right there. I don't care if it's a triangle, a quadrilateral, a parallelogram, a trapezoid, doesn't matter. If I do a 270-degree, and that point is A comma B, then this point has to be
-B.
well, no, it's a positive number on the x coordinate for sure. Let's see, I flip the sign. Yeah, -B, comma, A. And that may not look right because -B, it's a positive number, but obviously B is a negative number over here.
Yeah.
In other words, my original point, B is the negative number. It's actually easier if you use numbers rather than letters. Don't use letters, that's just confusing. Make up a -6, comma, -1. And now what's the new point?
1, -6.
Yeah. In other words, you can always figure out the formula by just picking up a point that's got 2 numbers that are far apart. You wouldn't be able to figure it out if I put a point like right there and called that 3 comma or -3 comma -4. After rotating it, I have no idea where it is. They're too close together.
Yeah.
So I wouldn't be able to use this to come up with my formula. I wouldn't be able to see it visually. But if I use a point up here, I know the new point's going to be down there. All right. That's it?
Yeah.
No last questions or anything? You certainly don't need to go a full hour if you don't have an hour's worth of material.
Yeah. I'm good.
Yeah, and I think you get this stuff.
Yeah, it wasn't too hard.
Yeah. Bradley, I'll talk to you next Sunday at noon. And all I will do next Sunday is text you the meeting ID number.
Okay, and then I'll just like get on there right at noon.
Well, here, before you go, let's have a look at my screen so you see what that icon looks like. See that icon, go to meeting? You should have that icon on your desktop right now. Do you?
Hold on.
You gotta minimize your your go-to-meeting control panel in order to see your desktop, probably.
Yeah, I have it.
Okay, that's what you want to double-click. Enter the meeting ID number. You'll go right in.
Okay.
Okay. And normally I try to get to that a few minutes before 12. Today I had an appointment from 11 to 12, so I was a little late. But next week that shouldn't happen. So you should have the ID number before 12. I will talk to you next week, Bradley.
Thank you.
Bye-bye.